Lesson 5.7, we're going to look at double angle and half angle identities. We're going to start with verifying them or proving them. So as you see here, to prove the double angle identities, we use the sum identities that we learned in the last lesson. So what we're going to do is we're going to come over to this first one here, and we're going to start by writing the sum identity for sine. So we know that sine of 2a, so we're not going to write it yet, we're going to say sine of 2a equals sine of a plus a, because that's what 2a means. But now we have this sine of a plus a, and that fits our sum identity for sine. And so we'll put that into our identity for sine. So this is going to be sine of a, of our first one, cosine of the second one, which is still just a, plus sine of the second one, cosine of the first one, which just ends up being 2 times sine a cosine a, because they're like terms, so we can add them together. And that is the sine double angle identity. Then we're going to look at the cosine double angle identity, and that actually has a few different forms, but we're going to start with cosine of 2a. So let's do the same idea. So cosine of 2a, that's just cosine of a plus a. And now we're going to use the cosine sum identity. And that, if you look at that, that's going to be the cosine of the first times cosine of the second minus sine of the first angle, which is a, sine of the second angle, which is also a. And we simplify this. This is just cosine squared of a minus sine squared of a. And so I'll rewrite this. So cosine of 2a, this is our first variation of the cosine sum identity. And we're going to get two other variations. And you might think or realize that we have some squared trig functions here. And we talked about if we see squared, sometimes we think Pythagorean. So what we're going to do is we're going to think of our Pythagorean identities, and we know that sine squared plus cosine squared of an angle is equal to 1. And so we can have different variations of this. So if we subtracted sine squared from both sides, we would get cosine squared of a equals 1 minus sine squared. And we can go ahead and put that in to that equation in the box. We can take out cosine squared and we can put in 1 minus sine squared. So instead of writing cosine squared, we can say this is 1 minus sine squared. And then minus sine squared. And we see that's 1 minus 2 sine squared of a. That is another variation of the double angle identity for cosine. And then to get the third variation of that, we have sine squared a plus cosine squared a equals 1, but this time we will solve for sine squared, so we'll subtract cosine squared from both sides. So sine squared a equals 1 minus cosine squared a, and we will use that still in this green box. We will put it in there, and so we have cosine of 2a equals, I'm copying the green box here, cosine squared of a minus sine squared, but from our Pythagorean, we know that sine squared is equal to 1 minus cosine squared A. And we can simplify that. So this negative would get distributed, which makes that cosine squared a positive. So we have 2 cosine squared A minus 1. And that is the third variation of the double angle identity for cosine. We're not going to jump in and use these right now. We can use them when we're verifying trig identities, but one thing they are used for is actually to help us prove the half angle identities, which come up next. So as you can see here, right under half angle identities, it says to prove the half angle identities, you're going to use the cosine double angle identities. And so we're going to take a look at that. And so the sine half angle identity, I'll show you what we're going to use here. We're actually going to start with this right here. And so we're going to start with cosine of 2a is equal to 1 minus 2 sine squared of a. And we're going to solve for sine of a. So our goal is to solve for sine of a, and then we're going to think through some things to help us get this half angle identity. So we're going to solve for sine of a, which means we're going to subtract 1 from both sides. And I'm actually going to write this. We don't usually write it in this form, but I'm going to keep this -1 first. So this is -1 plus cosine of 2a equals -2 sine squared of a. Now, I'm solving for sine of a, so I'm going to multiply both sides by -1/2, by -1/2, actually. And that's why I kept the -1 first, because when we multiply in the -1/2, in fact, this might seem strange, but I'm just going to multiply in the negative because that's the form that we want our identity in. So over here on the right, we have sine squared of a equals, and I'm just distributing in the negative, so I'm going to have the 1/2 out here. Distributing the negative, this would be 1 minus cosine of 2a. And to solve for a, the last thing we would do is take the square root of both sides. Now, when we take the square root when solving, we're going to put plus or minus over here. And so what we have, and I'm just going to switch the order here, sine of a is going to equal plus or minus the square root of 1/2 1 minus cosine of 2a. You might think, what's going on? I don't see anything about a half angle identity. Well, now what we do is we're going to let a equal 1/2 theta, or theta over 2. 1/2 theta, or theta over 2, whichever way you want to write it. But now we're talking about a half angle. And so any number has a half, like you can always find half of it, so that's what we're doing. And so we're going to plug in theta over 2 for a. And then we'll get our half angle identity. So sine of theta over 2 equals plus or minus the square root of 1/2 1 minus cosine of 2 times a, which we're letting a equal theta over 2. And we notice things cancel there. Running out of room a little bit here. So we have finally we have our identity here, sine of theta over 2 equals plus or minus the square root of 1/2 1 minus cosine of theta. And so what this formula does for us, or this identity does for us, is it allows us to find the sine of some angle if we know the cosine of double that angle. And we'll see that what's happening shortly with that. But that is the sine half angle identity. You see there's a plus or minus there at the beginning. It just depends what quadrant we're in. That's figuring out is the angle in the first, second, third, or fourth quadrant. All right, now we're going to do something similar, but this time we're going to start with this form, and we have cosine of 2a equals 2 cosine squared a minus 1, and this time we're going to solve for cosine of a. So we want to get cosine of a by itself, and it's going to be very similar. This time we add 1 to both sides. And I'm going to put 1 plus cosine of 2a equals 2 cosine squared a. We would then multiply both sides by 1/2. And that is going to give us cosine squared a equals 1/2 1 plus cosine of 2a. Take the square root of both sides. Make sure we put plus or minus. And we're going to again put this first. So we have cosine of a equals plus or minus square root of 1/2 1 plus cosine of 2a. And what we're going to do again here is we're going to let a equal theta over 2, or 1/2 theta, whichever way you want to think of it. And so when we plug that in for a, in for both a's into this in here, it will get us this half angle identity. And we get cosine of theta over 2 equals plus or minus the square root of 1/2 1 plus cosine of 2 times theta over 2, because we're plugging in theta over 2 in for a, which finally gives us our half angle identity for cosine, plus or minus 1/2 times 1 plus cosine. The 2's cancel, so cosine of just theta. And that is our half angle identity for cosine. So we developed those 2 identities. So in this lesson so far, we have learned the double angle identity for sine, 3 variations of the double angle identity for cosine, and then we use those to help us get the half angle identity for both sine and cosine.